Okay, welcome everyone. Thank you for allowing me to present in part my thesis, or a portion of my thesis, on in vitro protein quality in the context of pulses. I hope to give you a greater appreciation of protein quality and perhaps its impact on food systems and sustainability. So first we'll begin with protein content claims. And these have been one of the top 10 trending claims for the past decade, including in 2018. About 40% of new products introduced to the market have some kind of introduction or claim on protein. And 1 in 4 Americans are selecting for protein products. However, not all protein is created equal. We measure nitrogen as a means of assessing protein content. And so protein content is part of quality, and also the amino acid composition, or the total amino acids, which could differ between protein products. With protein quality, we look at essential amino acids to make these claims. So these are amino acids that the body cannot synthesize. We must acquire them from our diet, with the exception of 2 other essential amino acids, which are conditionally essential. There we go. And then we also have a difference between the source of protein. So if we're looking at animal-based versus plant-based, plant-based proteins can be limiting in some essential amino acids relative to animal-based proteins, but also their impact on the environment can be staggeringly different. And when it comes to pulses, these proteins pulses can be high in protein, and they're an economic crop here in Canada, and especially in Manitoba. And they may have impacts for weight regulation or weight management, which can have impacts on cardiovascular disease and diabetes. In Canada, we require what we call a protein efficiency ratio to evaluate the protein quality. This looks at a growing rat model. So we feed a rat, it grows, to make these claims. And this is what I would say a rather ancient claim or older claim, as these claims have been replaced. The World Health Organization and the FAO, as well as this next method, which is the protein digestibility corrected amino acid score, has been adopted by the US and other nations. Looks at collecting rat feces and measuring the remaining nitrogen and assessing what nitrogen remains as the digestibility, and we use those for protein content claims corrected for amino acids. However, my research looks at perhaps removing the animal bioassay and looking at an in vitro model for the PDCAS and replacing that digestibility component and still correcting it with the same amino acid component. However, selecting for an in vitro model can be rather challenging because these models, essentially you have to select 2 of the following, right? It's either fast and cheap or good and cheap. And whether these impact the protein content claim or quality claim should be answered to see if in vitro is a possible answer. So one of the methods I looked at is what we call the pH drop. And this is a method that when we add some digestive enzymes from the intestine to a protein source, that once the reaction occurs, you have a drop in pH, and we can correlate this to digestibility. In addition to that, we can do something that's more physiologically relevant, what we call a 2-step digestion. So we can do stomach digestion followed by intestinal digestion. And this process is a lot more complex and lengthy. So in terms of that cube or triangle we were looking at earlier, what that can imply. So the results that I find from the in vitro digestibility for the pH drop is a pretty good correlation. So here on the y-axis, we have our rat digestibility, or that feces, and then we have our pH drop. And then we also find that in terms of, in terms of probability, is significantly greater than 0, which isn't shown here. But when we correct that for the amino acids, for calculating protein content claims using this pH drop, we find that that correlation is also significantly increased, meaning that this method could possibly be used for that. But when we also look at the 2-step digestion, we have a similar correlation. Despite the increase in complexity, we find that the correlation is relatively the same for the 2-step digestion. And then when we correct for that with amino acids, When we correct for that with amino acids, again, we get the similar result. So when we're facing whether the method should be complex or simple, we can say that with this data group, with these pulses that were tested, that we can have a similar prediction in digestibility without an animal bioassay. And this can have several implications. For one, we can reduce the amount of animals used, but in terms of policy, we would have to look at changing either what the FAO or WHO is recommending by producing these types of results and correlations to show that in vitro processes could be used to remove animal bioassays. In addition, this could help to improve protein quality content claims for plant-based proteins, especially in pulses, which we already find either from whole sources, such as chickpeas in this example, or even in pulse-based snacks, breads, cereals. And then we can also get a better implication of if we're testing a variety of processing techniques and what that can have. So in terms of food systems and sustainability, we can find that processing, the production of pulses, and the impact that this can have on our health as Canadians, and also as from producers and processors, and economic impacts throughout. And now I'd like to take a second just to acknowledge my advisor, Dr. Jim House, and my assistants through my lab group with Dr. Noseworthy, Gerardo Medina, Kristen Hill, and Jason Neufeld, and my sponsors. Thank you.